warming of the oceans, it's one new disturbance after the other. I'm a pretty competitive person. We're going to figure this out. It's all about adapting. The organisms have to adapt, but we also have to adapt.
All right, so welcome back, everybody. Rich Brubaker, founder of Collective Responsibility, here to another episode of the Sustainable Ambassador Podcast. Through this podcast, I'm speaking with global sustainability professionals, academics, nonprofit leaders. For me, this is all about empowering the next generation of sustainable ambassadors, trying to figure out how they will use their skills, use their passion to deliver on some of these challenges. In this episode, I'm extremely excited to be joined by Stacey Williams, who is a marine scientist and co-founder of the Institute for Socio-Ecological Research based in Puerto Rico. Stacey and her team are focused on innovative ecological methods such as outplanting coral fragments and reintroducing sea urchins and crabs to help manage coral smothering algae. And I felt like, given how important coral and the oceans are to the health of our planet, speaking to an expert about what's happening, what they're doing, and why it's important was really critical to the conversations that we've been having. So with that, Stacey, thank you very much for taking the time to join us.
No, and thank you for the invitation. I'm excited to be on your podcast.
All right, so as a starting point, it'd be great to have a personal introduction about the work that you're doing and how you got there.
Yeah, my name is Stacey Williams. I'm one of the co-founder, also a marine biologist for a local nonprofit organization here in Puerto Rico called the Institute for Socio-Ecological Research. And we are a local nonprofit organization that really focuses on conservation, restoration of the resources, not only marine resources, but also terrestrial resources.
And how did you come into this work? Like, what inspired you, I guess, early days to get involved with coral conservation? Like, was there a moment in your childhood watching Jacques Cousteau? Was it in college? Like, what got you into this and what inspired you to make this your career?
Yeah, I was actually born and raised in Cleveland, Ohio, so very far from the ocean or any marine life. As a little kid, I was really interested in the unknown and the ocean. A lot of it is unknown. And my parents were very supportive of my desires and dreams of being a marine biologist. So, they would, like, for Christmas, buy me, microscopes, and every, like spring break, we would go to Myrtle Beach. And then I really had influential teachers in high school that pushed me, like in zoology class, to really go and study marine science. So I think it was like all of them together that really gave me the momentum to pursue marine biology as a career.
Mom's buying you microscopes. High school teachers are doing their job. They're indoctrinating you into saving the world. You go to college, obviously you're following that path, but what were some early career steps or maybe some field research that you got involved with as part of the process that were like really critical to the early days?
For my undergrad, the college that I went to was actually, I majored in biology, but I got a concentration in marine science. And for one semester, we either could choose to go to Alabama to Dauphin Island Lab Marine Station, which is off of Alabama, or go to a study abroad program. And I decided to go actually study abroad for a semester in Dominica, which is a small little island in the Caribbean in the Lesser Antilles. And there, just like it took off. That experience in Dominica really made me kind of like the basis of who I am today through that experience. Yeah.
What are the challenges that reefs are facing? I mean, we mentioned a few different things about bleaching and disease, but kind of break those down. Like, what are the major threats that reefs face on a normal basis? And, from there we can talk about how heat gets involved.
Yeah, so like climate change, but within climate change is like greenhouse gases, the warming of our oceans. I think that is like the largest disturbance that we're facing right now. I went diving yesterday at 60 feet. It is 31 degrees centigrade. And the corals, a lot of the corals are pale and a lot are bleached. And we're in October. So right now, I would say that is like one of our biggest threats on the coral reefs is actually bleaching due to warming waters. The other one is actually coral disease, and we saw that in 2019 with this really aggressive coral disease called stony coral tissue loss disease. This has spread throughout the Caribbean and has impacted not just a couple of coral species, but the majority of coral species. So due to this coral disease, we've seen a drastic decline in coral cover, and it is really not recovering. And some reefs, there is no corals left.
It's 31 degrees now at 60 feet. What was it when you first got there?
So the norm would be like, oh, the temperature would get up to maybe 26, 27. That would be like the peak. And then in like wintertime, it would get down to in Fahrenheit 78. So that is like 24, maybe. Like, so that would be kind of like the range. And now what we're seeing is that the temperatures, like it would, like we would see the lowest temperatures in February. That was like the hottest temperatures were in September, the lowest temperatures were in February. But now the temperatures are just really warm throughout the year. Like we're not seeing the lows anymore. And if we do see a lows, there's a drastic shift to warmer temperatures. It's not like a gradual shift like what we would see. Like in the month, you would see the warmer, like the water's starting to get warmer and warmer, in the months. Now it's like you turn on a light switch and the next day you have like 3 more degrees. It's this prolonged heating stress on the corals that is really impacting them. Corals have a really narrow range for them to survive and live. And if they're outside that normal water temperature range, if it's too hot for too long, we call those degree heating weeks. And the more weeks you have, the more stress the corals feel. So the higher chance, there's a higher chance that they're going to bleach or possibly like also die and not be able to recover from bleaching. So the corals can, like if they are in the optimal conditions, they can recover from bleaching. But right now, the conditions are not optimal on the reefs. So they're not able to recover, and a lot of them are dying.
What does it mean for reefs that this is happening? And let's say that we have this continued trend. Are they going to adapt? And if not, if they fail, what does that mean?
There are corals that we're finding that are more resilient to warmer temperatures. So those will be the survivors, and many unfortunately will not be able to survive these changing temperatures. So like corals are the framework builders of coral reefs. Like you need corals to have a coral reef, and they provide so many important services. And without them, we're going to see biodiversity loss, but also protection from hurricanes and storms and wave energy. There's going to be drastic consequences if we lose coral reefs, and corals particularly. Yeah.
So then what is the work being done to understand the impacts of climate change or heat to the corals? And then from there, how to restore coral? Like, are you having to pick certain corals? Are you creating new coral? Like, what's the approach here to create adaptation or to support the resolution of these challenges?
Yeah, so there's actually a really nice study that just was published by Margaret Miller and all that took corals that have survived previous bleaching events, and they reproduced them in lab, and they survived, they settled, and then they were transplanted. The babies were transplanted on the reefs, and they found to be more resilient and survive the last bleaching event. So there's this hope that we can create, I don't like to say the word super corals, but corals that can adapt to these changes. So corals are really unique organisms because they contain an endosymbiotic algae called zooxanthellae in their tissues. So corals need photosynthesis. They need the sun because this zooxanthellae gives them half of their nutrients. So, but they also give them the color. So when the corals are stressed, the zooxanthellae leave the coral, this algae, and so that is when they become white. So they're not necessarily dead, but they're like half of them have lost, like half of their nutrition is gone. Other scientists are finding that there are more resilient zooxanthellae that can adapt to climate change. So it's inoculating corals with these symbiotic algae that possibly could help corals survive more and more higher water temperatures. So there's a couple of different approaches that people are taking to try to adapt to climate change.
You have a stress, you have a bleaching, you have coral dying. Do they naturally repair themselves? And what's the process or what's the timeline for that? Because I remember seeing a lot about, the Great Barrier Reef was under stress and it was dying and it was bleached. But then I remember seeing articles very quickly that it's all come back. Is that a natural process that we just need to give time and it's possible that all just comes back? Or is it really like we're reaching a point where even natural systems for adaptation, rehabilitation have been disrupted?
Yeah, so it's all dependent on the location and what's happening there. Like for Puerto Rico, the last bleaching event of last summer, the corals were already paled in the beginning of this summer. So they did not recover because the ocean waters didn't get cool enough. And we're seeing that is like, as I mentioned before, is that we're seeing prolonged periods of time when the waters are just warm. It's not getting cool enough for a long period of time. So these bleaching events are prolonged, and they don't have, a lot of these corals don't have a chance to recover. Before stony coral tissue loss disease, what we were seeing here in Puerto Rico is that reef corals that were actually located in areas where there was a lot of high organic turbidity, meaning chlorophyll, they were less impacted by warming waters because they had a lot of food. So even if they lost their zooxanthellae, they had a lot of food to feed on in the water. But it also created kind of like a sunblock because usually with organic turbidity, the water's not so clear. So you get like a natural turbidity. And that also protect them from UV radiation. But then you threw in the mix of coral disease. So those coral reefs that were actually coming back, we're slowly coming back and we're like very hopeful for. We're just hit by stony coral tissue loss disease. And
let's switch it up a little bit and talk about like the restoration process. You have these events, you have these stresses. What is the work that you're doing to understand how to rehabilitate? What are some of the what are some of the experiments you run, or what are some of the things that you do to follow it? Like, what's the process for, your work to help restore the reefs that you're working with?
yeah, so after a lot of these events, when corals actually die, what succeeds them is algae, which is seaweed. It could be a fleshy algae. It can be this encrusting pacinellid, which is like an encrusting algae that's actually pretty harmful. It can overgrow and kill coral tissue. So those usually succeed coral heads when they die because seaweed grows fast and they love light and warm water temperatures. So it's like optimal conditions for seaweeds. If you have all this seaweed, it has cascading effects. Corals are not going to be able to settle there or grow there because they're being outcompeted by the seaweed. So in order to improve these conditions, I was like, why don't I grow the sea urchins to larger sizes and then release them to the reefs so they can kind of prepare that reef for recovery. And that's how our restoration started really back in, I received small amount of funding from NOAA in 2015. And since then, we have slowly been growing, and we are the first land-based coral, sea urchin, and crab nurseries here in Puerto Rico. And the approach that we're taking is more a holistic ecosystem-based approach to coral reef restoration. We're just not outplanting corals, because if you just outplant the corals to the conditions that the reefs are right now, most likely they're not going to survive because they're going to have to outcompete this seaweed. What we're doing is that we're also releasing herbivores to help maintain and control this algae to give the coral outplants a better chance of surviving. So when we outplant corals, we automatically release either sea urchins and hopefully soon herbivorous crabs. So they were taking a different approach to coral reef restoration.
Now, when you're releasing these urchins, these crabs, are they native to that area and you're just bringing them back and say larger numbers that would normally be found? Or is this something like Monterey Bay, or they're just going to potentially take over and we've created a new problem? But
Yeah, so we have also experimental studies that tell us what is the ideal density to release these urchins. Because yeah, you don't want to release thousands of urchins to this reef, and then you'll have these negative impacts like urchin grounds that are eating everything. We try to maintain the densities within the ideal ranges, and to make sure that there's no negative impacts to releasing urchins, because if you release too many urchins, they actually will erode the reef. So they'll eat away at reef structure, and that's not what we want. We want them just to eat algae and maintain that area clean for corals and other organisms like sponges to grow.
how long does it take before you're confident that you know that you have, say, the right approach or the right balance? And how do you, like, how many experiments do you have to run, and what's the role of that process before you even go out and say, okay, now we're going to release our first urchins? Like, how long does that take? And, how many different types of scenarios are you running before you find that you're confident?
Yeah, you want your experiment as robust as possible. So like when you're saying, you're generalizing, oh, this is the ideal density for this urchin to be released, you just don't want to focus in one area. You want to do this experiment in multiple areas to say, okay, in Puerto Rico, what we found is that, okay, through these different areas at this location for this amount of time, and this amount of replicates, because that's like the amount of different same experiments. The more replicates you have, the more robust your study is. And less variance. You don't want too much variance in your study. So that way you can then hone in and say, okay, this is what we can do. We can, these are the amount of urchins that we can release. This is the amount of time that we see, them impacting, positively the reef substrate. All of this is through these experiments. So they could range from, a couple months to many years experiment. And with our restoration project, our large restoration project, we're actually, before we do anything to the reef, what we do is baseline data. So we collect data to help us measure, okay, what is the coral cover at this reef? What is the fish diversity at this reef? Like, how big are the corals? What are their conditions? What is the seaweed look like? What is, what's the dominant species of seaweed? And so with one of our partners, like HJR Reefscaping, what they do is they go down and they take orthomosaics, and it's just like a mosaic where they take multiple pictures in a set area, and then those pictures are basically combined into one large picture. So you have a really big landscape of that one plot. And that's what we do before, during, and after. So we can see, okay, what are the impacts that we're doing on those reefs? And if we need more urchins, or if we need less urchins, or more corals, or this species of corals, it did well, so with this data, you can then determine how to move forward in the future.
Actually, when you're looking at these pictures or you're looking at your data, like, what are some basic signs that you're on the right track? Like, is it just a cutback in algae? Is it specific, like, coloration? Like, what are the top 2 or 3 things that you see, and how long would you say it takes to see some of these things? Is it pretty immediate, or are we talking months and years?
So depending on what you're looking at, like for seaweed, when we release urchins, usually we see a difference within a week, 2 weeks. So for like reducing algae, some of these like urchins can be like a couple weeks to a couple months that you're going to see a difference. So if we see that, okay, algal cover was reduced, we're good. We're on a good track, like that's great. And there's clean substrate. Another thing that we want to see is like, okay, the corals that we outplant, are they surviving? Are they actually growing? And that is something that we can measure through photographs, and through these orthomosaics. We can actually see, okay, yeah, these corals are surviving. What are the conditions? Are they paling? Are they stressed? If they're paling, that they must be stressed. Or are they growing? Are they getting bigger? And with corals, because they grow very slow. I mean, an adult colony can grow here in the Caribbean between 2 to 4 centimeters per year. So that is really slow. But when we cut corals in small pieces, what we call microfragmentation, they actually grow quite quick. So we can start seeing them grow slowly in our orthomosaics and our actual pictures that we take when we go out and do this monitoring.
So that's a reasonable amount of time to figure out if you're on the right path. In the meantime, what are you doing? Do you like, if you put out your first 1,000 or 10,000 urchins, do you wait until you get the first resolution of pictures back a week, 2 weeks later, and be like, okay, we have the right balance? Or do you kind of, additive, and then do you wait for them to clear cut before you start planting new coral? Like, what's the general process? And, you mentioned microfragmenting, like, are there things that you can do to kind of game it?
Yeah. So when we started doing like this simultaneously releasing urchins with corals, we made the mistake of like releasing urchins before outplanting corals. And when we outplant corals is that we use cement. We mix cement on the boat, we take wet cement down, and we form these balls that we can actually place the coral fragments in. So with the urchins, they were getting in the way. So like cement, like it was just not a good combination. And the sea urchin that I work with is actually has really long spines, and they're painful if you get pricked by them. So it was not a good combination. So what we do actually is that, and with our partners that do most of the outplanting, now that we are kind of in control of producing the animals, is that they go out and they just gently clean the substrate. They, outplant the corals in these cement structures. And then once that cement is cured, which is like a day or so, we then release urchins. And we do go, even though we don't go out and monitor them with photographs, we are out there monitoring them, observing them, and you can definitely see if something's going on.
Now, bigger picture, are you keeping up with the challenge? And who is working with you? Like, who are the stakeholders that you work with on a regular basis? And do you think that it's enough right now, or we really need a total seismic shift in resources and attention on this issue?
So this project is like, I hate to say, like a little band-aid of a much larger project. Problem. The warming of the oceans, it's like one new disturbance after the other. It was like bleaching, now a new coral disease. And then, in 2022, there was another die-off of the sea urchin, the long spine sea urchin. So it's like we have to constantly adapt, like adaptive management, like figuring out, okay, how to keep up with all of these disturbances. So it's really until we combat climate change and reduce greenhouse gases and the warming of our oceans, it's going to be this constant battle. And there's people that are, and we're working with that we're trying to figure out, okay, like how to make these more resilient corals, like through sexual reproduction. Like, we know like from the corals that are actually survive these different disturbances, they seem to be more resilient. Okay, let's reproduce them. Let's cross, gene or crossbreed those two colonies to make hopefully stronger corals. And so we are working with, we have colleagues in Mexico and Dominican Republic that we're working with to build that laboratory here in Puerto Rico. We were successful in sexually reproducing corals this past summer, but next summer we are really going to hone in on that. And I think that's the way to go, is that trying to produce these more resilient corals. It's going to take a lot of creativity and it's a lot of money. Like our land-based nurseries cost a lot to run because you need the personnel, the energy costs. Like we are lucky that we have most of our stuff on solar and we're going to be on solar. But it definitely is a high cost. And we've been receiving a lot of support. NOAA's our biggest funder, the Restoration Center. They have been also National Fish and Wildlife Foundation, U.S. Fish and Wildlife, the local Department of Natural Resources and Environment. It's the NER. yeah, so there's been multiple stakeholders that have been actually giving us support.
That's a lot of government stakeholders. What is it about them that's driving this? Like, what's driving them to focus on this issue and put so much into it? And are they the only stakeholder, or do you need more to come in? Like, do we need a whole different body of organizations to come in and find importance here?
Yeah, so that's actually what we're working on right now, because it's not sustainable being on soft money on federal funds, because you have no idea what next year or the next 4 years are gonna hold. So we are trying to figure out how we can fundraise to sustain our operations and continue to do what we want, like what we love to do and what is good for the reefs in the Caribbean. Yeah, it definitely like like, and we what is our main overhead is like paying salaries. And we hire a lot of local people here. So in Puerto Rico, it's like a brain drain. A lot of young, career driven people leave the island because there are no opportunities for them, especially in science or marine science. And through our projects, we've been able to hire a lot of these recently graduated students, also graduate students that are currently studying, our undergrad students in our nurseries. So they have a job, they can study, they actually use some of this data to complete their thesis work or dissertation work. So like that is like a lot of our overhead goes into salaries and keeping local people here and building this economy, as they call blue economy, in Puerto Rico.
That's great. A few more questions. I guess the big one I have right now, after having a discussion around resources and seeing some kind of anxiety showing through there, what keeps you passionate after so long? I mean, you've been diving for 20 plus years. You're seeing the challenges grow. How do you keep going? Like, what is it that you hold on to? What is it that you see that really pulls you through these times? And what's driving you to keep going when you say that you're just a little band-aid on this problem?
Yeah, it gets daunting. Like every summer, you see a different disturbance or something's happening. But I also see, like, we work with really passionate people, like our partners. They really care for, the marine ecosystem, and they're passionate in improving this. And I think that like their passion, like the people that we work with, our employees, like that passion like keeps you going. And I'm a pretty competitive person, so like I like that drive of, okay, we're gonna figure this out. Like, yeah, this is some things happening, but there's a lot of smart minds out there that are working towards improving coral reefs and saving corals. And that, I think, is what drives me to not lose hope, but also to continue on like pushing and figuring out some better solutions, because it's all about adapting right now. It's like it's changing by months, like it's, yeah, us, like the organisms have to adapt, but we also have to adapt.
All right, last question. What advice would you give to an aspiring marine biologist from Cleveland, or conservationists who are looking to make an impact in your space of coral reef restoration? Like, what should they do? 2 to 3 things to get their career started as marine biologists to have an impact on this challenge.
So my biggest, advice would probably be is to get out there, get as much experience, because it also will help you figure out what you're interested in if you want to pursue, a master's or doctorate degree in marine science, and not to be afraid to fail. Failure is sometimes good, and to encompass that and to move on and to improve.